So, when you look up at the night sky, what do you think it's all made of? The stars, the galaxies, all that glowing stuff? It just seems endless, right? Well, what if I told you that everything you can see, everything we've ever been able to touch or detect, is barely a speck of what's actually out there? Yeah, let's dive into this massive cosmic mystery.
Just look at this. This is basically the recipe for our universe. A truly staggering 68% is something we call dark energy. Another 27% is dark matter. And that tiny little 5% sliver over there, well, that's us. That's every star, every planet, every single atom we know. Everything we think of as normal is just 5% of the total cosmic pie.
Which, of course, leads to the most mind-bending question in all of modern science. What on Earth, or, what in the universe, is the other 95%? This is one of the biggest puzzles we've ever faced, and today we're going to break down what we think we know, and more importantly, what we don't.
Okay, let's tackle the first piece of this invisible puzzle, dark matter. The whole story here is a classic tale of science, where the universe just wasn't behaving the way our rules said it should.
It all started way back in the 1930s. An astronomer named Fritz Zwicky was looking at this huge group of galaxies, the Coma Cluster, and he saw something that made no sense. The galaxies were moving so ridiculously fast that the gravity from all their visible stars couldn't possibly be enough to hold the cluster together. They should have just flown apart millions of years ago. Then, fast forward to the 1970s, and Vera Rubin sees the same exact problem, but inside individual galaxies. Stars way out on the edges were orbiting just as fast as stars near the center. That's a huge red flag. Physics says they should be moving way, way slower. It was like some invisible source of gravity was giving everything an extra tug.
So you've got these two completely independent lines of evidence, decades apart, but they're both screaming the same thing. There has to be a ton of invisible stuff out there, providing the extra gravitational glue that holds the cosmos together. And they gave this mysterious stuff a perfectly mysterious name, dark matter.
Okay, so you're probably thinking, if you can't see it, how do you know it's there? Great question. One of our best tools is a wild phenomenon called gravitational lensing. Basically, Einstein taught us that really massive things literally warp the fabric of space and time around them. The classic analogy is a heavy bowling ball on a stretched-out rubber sheet. Any light that travels nearby has to follow that curve. And this is how we manage to see the invisible. As light from a super distant galaxy travels across the universe to us, it passes through this dark matter. The dark matter's gravity acts like a giant cosmic magnifying glass, bending and distorting the light. By studying those distortions, astronomers can literally map out a vast, invisible scaffold that structures the entire universe. It's wild.
All right, so that's dark matter, the invisible glue. But now we've got to talk about the biggest and, frankly, the weirdest piece of the puzzle, that giant 68% chunk we call dark energy.
So since 1929, we've known the universe is expanding. For most of the 20th century, the big debate was whether gravity would eventually slow that expansion down or maybe even pull everything back together in a big crunch. But then, 1998 happened. Two teams of astronomers were looking at distant exploding stars, supernovae, and they found something that completely blew everyone's minds. The expansion wasn't slowing down at all. It was speeding up.
To explain this, scientists had to come up with something new, something even stranger than dark matter. They called it dark energy. And unlike gravity, which pulls everything together, dark energy seems to be some kind of repulsive force that's pushing everything apart, faster and faster. It's like the universe has its foot on the gas pedal.
Now, it would be nice and tidy if the story ended there. Dark matter pulls, dark energy pushes. But of course, it's not that simple. The more we look, the more complicated things get, and the science is anything but settled.
This is where it gets really juicy. Take a look at this quote. In science, sigma is basically your confidence level. A 5 sigma result is the gold standard. You're pretty darn sure. What you're seeing here is that two different major studies of supernovae are giving us different confidence levels on a huge question. Is dark energy's strength constant, or is it changing over time? And that disagreement is a really big deal.
This chart just makes that conflict clear. One set of data suggests dark energy might be evolving, while another is kinda meh on the idea. Now, why does this matter? Well, it could mean there's a tiny error in one of our telescopes, or it could be the first hint that our entire standard model of the universe is just plain wrong. And once you start questioning one thing, it opens the door to questioning everything.
This uncertainty has led some scientists to go back and look at our other big mystery. What if we've been on the wrong track all along? What if dark matter isn't some crazy new particle we have to find? So here are the two big ideas. The mainstream theory says dark matter is some exotic particle. But there's this really fascinating alternative idea gaining some ground. It suggests the lensing effect we see isn't from gravity warping space-time at all. Instead, it argues that light is just refracting, bending, as it passes through a transparent web of normal matter. Think about how a straw looks bent in a glass of water. This theory says dark matter might be a cosmic optical illusion on a grand scale. And get this, proponents of this idea showed they could actually create the same kinds of weird, distorted galaxy images we see from lensing, but in a lab. They didn't need a massive object's gravity. All they needed was a carefully crafted piece of transparent material. It's a compelling argument that maybe we're looking at an optics problem, not a gravity problem.
Okay, so we've got conflicting data, competing theories, a real scientific showdown. So how do we break the tie? Well, we need better data. A lot more of it. We need a new set of eyes on the universe. And lucky for us, that's exactly what's coming.
Everyone, say hello to the Nancy Grace Roman Space Telescope. It is an absolute beast of an observatory, and it's being built specifically to tackle these enormous questions of dark matter and dark energy.
To really get a sense of why Roman is such a big deal, you just have to remember one number: 100.
Roman will have a field of view 100 times bigger than the Hubble Space Telescope. Let that sink in. In a single picture, it will capture an area of the sky that would have taken Hubble 100 separate photos to cover, all with that same amazing, crisp detail. It is going to be a fire hose of cosmic data.
And here's the battle plan. Roman is going to attack this problem from every angle. It's going to map dark matter with incredible precision. It's going to survey thousands of new supernovae to nail down the cosmic expansion rate. It'll build gigantic 3D maps of galaxies to see how dark energy has shaped the universe over time. Basically, it's designed to create the exact kind of massive dataset we need to settle these debates.
But here's the real secret weapon. Because Roman uses all these different methods, it can cross-check its own results. This is absolutely critical for finding and eliminating the subtle errors that are causing all the confusion right now. The goal is to make one single, super robust map of the 95% of the universe we can't see.
So, what's the bottom line? The bottom line is that we are standing right on the edge of a new era of discovery. The data that's about to start pouring down from space could change everything we think we know.
And that leaves us with this final, tantalizing thought. As we get this incredible new view of the universe, a view that's 100 times wider than anything we've had before, are we finally going to solve its darkest secrets? Or are we just going to find out that the rabbit hole goes even deeper and that the universe is far stranger than we ever dared to imagine?